Investor Connect podcast program. This is Hall T. Martin. I'm the host of the show, in which we interview angel investors, venture capital, private equity, family offices, and many other investor groups for startups and growth companies. I hope you enjoy this episode. Thank you for joining us. Well, hello, this is Hall Martin with Investor Connect. Today I'm here with Moshe Shadmon of AnyLog. Moshe, thank you for joining us.
Yeah, hi, Hall. This is very nice talking to you.
Well, great. We appreciate your joining us today and talking about your current company, AnyLog. But before we get into that, what were you doing before you started AnyLog?
Well, my entire career was in projects relating big data. Actually, all those projects were in companies that I started. My previous company was called ScaleDB. This was a time series database that optimized time series data, which is basically the data which is generated from all those sensors and smart devices that we see nowadays everywhere. So we managed this type of data, and ScaleDB was able to create a platform that was, I believe, the most efficient in managing this type of data. And it ended with a merger with a company called OSIsoft, which is the biggest provider for backend software for the industrial IoT. So they've seen the work that we've done. They were very impressed and were interested to do something together. So that was kind of a few words about my background.
Well, great. So when did you start AnyLog and how did it come into being?
So really there were a few things that were the drivers to start AnyLog. The first is obviously my background, which I was always intrigued by how to manage big data very efficiently. That's the main thing that I've done throughout my career. And when we started to work with OSIsoft, with my previous company that I mentioned, we saw the challenges that companies were facing when they had this huge amount of IoT data. So it's not just about the huge amount of data, it's also about the velocity and the speed in which the data appears. And that creates very interesting challenges that in AnyLog we were looking to address. In addition, I've noticed the new technology, which is based on the blockchain, which people started to use. And all of that created the idea that there could be a different way to manage data, that IoT data needs a different platform, and that's what we've done in AnyLog.
So who is the offering for? Who is the biggest user of your type of solution with AnyLog? Time series data can be used in a lot of different ways, but it sounds like you're using it with IoT, but who is your ideal customer?
So you know that IoT usage is growing very rapidly. We're getting close to 50 billion devices that generate data. And if you look at the amount of data, of IoT data in the world, it duplicates itself every 2 years. And it's in every industry. If you look at industrial, oil and gas, smart cities, automotive, assembly lines, all of these industries sees the huge growth of data which is generated from those connected devices. And that's a big challenge for all those companies. And that's what we do. We create a platform that any company could manage, could leverage and manage the IoT data very, very efficiently and in a very cost-effective way.
So what's the challenge with time series data? Why is that an innovation versus just taking a data stream as it comes? What are we doing that's different?
Well, I think there are two big things which are unique with IoT data. First is the huge amount of data. People that work in the space know that if you could take some data and fit it in some memory of a computer, you could manipulate the data and do a lot of work with it and even be efficient. But when the data doesn't fit into a single machine, that becomes a big issue. So that's one of the challenges is the huge amount of data here. The second one is something which is more unique to this type of data, which is time associated with it. So it's not just about an event, it's an event that relates to some time interval. And there are lots of events that show up and show what happens in different time periods. So the management needs to take care not of the huge amount of data, but also they need to take care of the time, how the time is related to the data, and that places specific challenges on the management of the data.
I've done some work in different engineering applications before and have found that time has many different elements to it. There's absolute time, there's relative time, there's wall clock time. And then in event series, there's time slicing as well as time stamping. What is the element of time going on here? Which of those concepts do you have to pull in to make your application work?
Well, the way we look at time, or companies look at time, and is where they want to know what is going on now or within some time interval, and usually compare it to what happened in a different time interval. So you've got, for example, in the industrial, you've got an engine that is working and generates data, and you want to know whether everything is working properly. And one of the best ways to do it is to compare it to a different time interval or to a different similar engine that generates a similar type of data. So with those observations, you could know the state of things and you could predict what would happen in the near future, whether something is going to fail or if something is not working correctly, and you could take all the measures that are needed in advance. So that's usually it's a process where companies want to understand what is going on now and compare it to some other time interval where they think things were okay.
So you made it possible to pull out different time segments and compare one to the other, whether it be a single event or a series of events, but you can take multiple time segments and do analysis and comparisons between the two, and then you can make predictions about how the device is going to react or last down the way. Is that correct?
That is correct, and that is something that most companies or all companies want, and especially with the adoption of AI and BI systems. And this trend is also going to accelerate with the adoption of 5G networks. So this is something that is going to be part of any company in the very near future.
Are you able to search through the time sequences and find patterns when you start putting together artificial intelligence systems? You're looking for particular patterns, and doing pattern matching became a big element of comparing one time result to another time result. How does that work in your system?
Right. So this is something that many companies are interested in. We actually don't do the pattern. We don't specialize in a particular domain to understand pattern. We are giving the back end. We are replacing the need for the companies to collect and store the data. We provide them an interface, a SQL-based interface. When they need the data, they could get it super efficiently without putting a lot of effort in managing the data. So you could think of us as the back end for all those AI and BI systems. And you could think about us as a platform that does it super efficiently and at a very low cost.
Are there any particular applications you can talk about and how they use your system?
So the cases that we see all the time are predictive analytics, where you want to understand how a particular equipment is going to behave based on the data that is giving now. You could see it in smart cities, where they want to understand, to know where people are, where cars are, is there roads which needs to get special attention so that traffic would flow more efficiently. You could see it in oil and gas, where understanding the state of the machinery is super important, because if a machine fails, this could cost millions to the company that operates those machines. A few days of a big machinery or equipment that doesn't work has enormous consequences. So it's really everywhere. Every company is now being adjusted such that they could operate more efficiently based on the data which is generated from all those devices. And so we see this growth in usage of IoT data, and therefore there is a need for an automated and efficient way to manage all this data which is being generated from all those devices.
I assume all this data is being stored in the cloud. What's an average data size from an IoT device over, say, 6 months or a year or some time frame? How much data are you actually collecting? Is it every millisecond, every microsecond, every second, every hour? What's the frequency on these things?
So it depends. There are devices that generate constant data, and we're talking about even terabytes of data. A group of devices that is connected to some device could generate bytes of data. Think about an airplane wing. Only on the wing, there are 10,000 sensors. The new cars that are built are full with IoT devices. So you could see places where we're talking about generations of terabytes of data a day. Now, what's interesting in what we're doing compared to how the industry works, today, companies manage the data through multiple tiers. They first collect the data and aggregate it outside the cloud. Then they filter the data, and only a portion of the data ends at the cloud. And that's because of many reasons, huge amounts of data. The cost of pushing all the data to the cloud is very high. Sometimes it is such enormous amount of data that it's not practical even to think about putting it into the cloud, and you need something the edge of the network. So what we're doing, we're basically replacing all this architecture with a single tier architecture where devices store the data either outside the cloud or in the cloud. It doesn't matter. They pick the best place to store their data based on the performance and the scalability that they need. It could be on the device itself. It could be next to the device. It could be in the cloud. We use the blockchain to understand how the data is distributed. And so on the blockchain, we've got all the information that say that particular devices generated data and the data is stored on particular servers. And then when users need the data, we're able to approach all those servers that maintain the data and bring the data to the application or the user in real time. So think about a car company that is looking after a particular performance or behavior of a particular model and wants to know how many near accident happened to this particular model in the last 2 days. We would be able to identify where all the data which is related to this car exists and bring the data to the user and the application in real time. So it takes care of all the management of the data. Companies don't have to do this complicated process of transferring the data through multiple tiers and filtering the data and doing a lot of work, and then at the end of the day, putting the data at the cloud. All that work is not needed with what we're building.
Is that why you chose blockchain? Is it eliminates all that processing, or what is the main advantage of blockchain for this application? Typically, you hear it used for financial payments and immutable ledger, so it can never be changed or compromised. But in this particular case, what do you see as the main advantage of blockchain for time series data?
Yeah, I mean, the blockchain is an amazing concept, and I was intrigued by seeing the blockchain and how it is able to manage financial transactions. And when I started AnyLog, my main idea was to leverage the same type of concepts that are managing financial transactions to manage data transactions. And the idea is that we're using the blockchain, going to your question, we're using the blockchain to achieve completely decentralization of this network that we're building. So nobody owns the network, and the network is self-managed. So if something is written on the platform, on the blockchain, it's safe and it is there. Just to make it clear, we don't put the data on the blockchain because the blockchain is not performing efficiently enough to capture all the data. We keep the data off the blockchain, outside the blockchain. But the blockchain keeps the metadata. It tells us where the data that we need exists. You could think about it like an index over the data. So when somebody needs the data from the information on the blockchain, we're able to identify the data and service the application or the user with the data in real time. Therefore, this is a super efficient system, and the blockchain allows us to do it in a way where nobody controls it. It's decentralized, so every company would feel very comfortable to use it. It gives the security that companies are expected to see in an environment like that. And it creates really a platform that not only allows companies to manage their data very efficiently, but they could also share the data in a very interesting ways. And all of that is given by the blockchain.
I see. That makes sense. Blockchain is not that efficient, but it is certainly secure, and it's certainly good for sharing information because everyone can have access to it. But you put the actual data offline and you're just indexing out to it and people can access it through the blockchain. That's a very clever idea. And I think a lot of groups can make use of that because The knock against blockchain is the scalability and the speed of transactions. If you put all the data inside of it, it goes very slowly and can be certainly not real time or not fast enough for most applications. So it looked like a pretty interesting application there for it as well. Were there any other benefits of blockchain aside from sharing it and making it secure and making it easy to access? Were there any other advantages you found in putting it together?
Yes, the idea is that the entire process of storing and processing IoT data is automated. So we leverage also the payment mechanism that the blockchain offers. So devices could figure out independently where is the best place to store their data. It could be on their own data center or their own managed machines, or it could be on third parties' machines. And so everything is automated, and the devices determine where is the ideal place for them to store the data according to what the organization that owns those devices wants. And then the payments, if we take a third party to store the data, if I want to store my data on Amazon or on a third party data center, I need to do the monthly payment. So we use the blockchain also to do those payments. And you could think about it as a reward mechanism that allows parties to participate in kind of an ecosystem where devices show up to this network with the goal of managing their data efficiently and willing to pay. So it's also an incentive for data centers and companies that have storage and compute resources to join the network as well and monetize their storage and resources. So this blockchain not only is a key component that allows to manage the data very efficiently, it creates an ecosystem where devices and data centers or companies with compute resources are able to join. And in a way, it creates kind of a share economy of storage and compute.
That makes sense. You use the token aspect of blockchain, but it becomes more of a self-managing system where it's taking care of itself, finding the best place to store the data, storing it, negotiating price, and potentially compensating people, potentially with tokens, I guess, with using the ecosystem that you built around it. Are you actually using tokens, or do you have some other mechanism to reward those who participate in the platform?
Well, right now we're in POCs, so we don't push those reward mechanisms, but it would be using tokens, yes, to reward.
That makes sense. Well, that's very interesting. In the last few minutes that we have here, what else should we cover that we haven't?
I think there is a very interesting question that sometimes investors ask me, which is this: they tell me it's a great technology, it's a great way to manage data, we understand the ecosystem that you are creating here, but it looks to us as a type of problem which they call the chicken and egg. So the claim is, if there are not enough service providers on the platform, then it's hard for a company to join to this ecosystem. And from the other side, the data center wouldn't join unless there are many, many companies that that are looking for places to store and process their data. So the answer to this chicken and egg problem is that it doesn't exist here. Because the reason, if I'm a data owner, let's say I'm a smart city, and I have a lot of data and I want to manage it, and I'm, let's say, the first one that would work on this network, the reason that I would join the network is because it is super efficient. It doesn't require the data projects on my side. I could just connect my devices to the network, and the data is self-managed, and I could immediately run queries. And to do that, I don't need a third-party data center to show here. I could take any local data center and join and download the AnyLog software to this data center and manage my own data. So in a way, I'm self-managing my data where I'm playing both sides, the data owner side and the data center side. And the value for me is that I don't need to go and do all the data projects. I don't need to push a lot of data to the cloud and write those big checks monthly for data management. It's all being managed in a very efficient way in real time no scaling limits, and at a fraction of the current costs. So the chicken and egg problem doesn't exist, which I think is super interesting.
Well, that's a great way of making the systems much more self-sufficient and useful for the users, because I believe you're right. IoT is coming up fast and it's going to generate a lot of data, and we're going to have ecosystems to support that data structure as well. How best for listeners to get back in touch with you?
So I think sending me an email, I could share my email. It's moshe@anylog.co. I'm also on LinkedIn. I'll be very happy to communicate and talk with any one of the listeners that wants to comment or ask me a question.
Well, great. Well, I'll put that in the show notes. We'll also put your LinkedIn profile up there, and looking forward to having you back for an update soon. Appreciate your taking time to talk with us today.
Thanks a lot, Al. Thank you very much. It was a pleasure talking to you.
Investor Connect helps investors interested in startup funding. In this podcast series, experienced investors share their experience and advice. You can learn more at investorconnect.org. Paul T. Martin is the director of Investor Connect, which is a 501c3 nonprofit dedicated to the education of investors for early-stage funding. All opinions expressed by Hall and podcast guests are solely their own opinions and do not reflect the opinion of Investor Connect. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions.